My name is Giancarlo Crespo, and this is number 39. Determine whether the following series converges or diverges. So first, we're tasked with finding the sum of the infinite series, the sum from n equals to infinity of cosine squared of n divided by the cube root of n to the fourth power, simplifying the general term. So first off, we can simplify our general term to show that it is equal to cos square n, n to the 4 over 3. And we define it as the general term an. Now, we got to figure out what we're going to use. I decided to use the direct comparison test. Why? Because we can easily simplify using the asymptotic hierarchy and the fact that as we go to infinity and as cos square n only goes from 0 to 1 because cos n goes from negative 1 to 1, but squaring it gives us only 0 to 1, we can define the term bnn as 1 over n 4 over 3. And because that is our bnn, we can show that 0 is less than ann is less than bnn. To just make sure that we're on the same page, the reason why this is so is because since cos squared n only goes from 0 to 1, then compared to 1 over 4 over 3, it is always either less than 1 over 4 over 3 or equal to, because it is either a 0 or it is a fraction, and then the fraction is less than whatever the bnn would be. And this is the direct comparison test. So now we have to find out whether bnn converges or diverges. Now, what we can see here is that bnn is 1 over n 4 over 3, and that sets up almost exactly the setup we need for the p-series test. It is 1 over n to the p, or a number, and this number is 4 over 3. So then we use the p-series test and find out that 4 over 3 is greater than 1. And since 4 over 3 is greater than 1, that means that this series converges. So the sum of n equals to infinity of bnn, or 1 over 4 over 3, converges. Now, using the direct comparison test and putting it all together, we know that bnn, or 1 over 4 over 3, converges, and our ann is cos squared n over n 4 over 3. And since 0 is less than or equal to ann, and it is less than or equal to bnn, since bnn converges, then ann also converges. Therefore, by asymptotic hierarchy, the p-series test, and the direct comparisons test, the sum from n equals to infinity of cosine squared of n divided by the cube root of n to the fourth power converges. Thank you.